Hi, welcome back. We're going to talk about lesson 1.2 and 1.3 today. So get out your theorem sheet and we're going to, at the end, there's a section for your definitions. So we need to add to it array. Array is just part of a line. So, a line extends in two directions. Array would extend in one direction. So you have an endpoint and then it extends. And so since it goes forever in one direction, we need to make sure to put the arrow. Now on this array, there's an unlimited amount of points on it. Now, it doesn't really matter how many points are on it. When you name it, you're going to name it with the endpoint and then any other letter. So this array essentially has four names as it is now. You can call it a B, and when you draw it, you put an arrow to the right. It always goes to the right. You could name it a C or a D. Now, common mistakes. If I were to draw this going to the left and put this as cat, a lot of people would confuse this and maybe call this Ray cat, maybe, or say, okay, I need to start with the endpoint, which is T, and then choose a different letter, A, and then they would draw the arrow to the left. And I realized this arrow on the diagram goes to the left, but we know when you write this, it always goes to the right. This indicates this is the endpoint, the T, and it goes on toward A. And if you were to write this going the other way, that's indicating, hey, I'm starting at A and then going toward T. So don't make that little mistake. And it doesn't matter what direction you draw it. Again, just follow the rules. Start with the endpoint, go to another letter on the array. So I can choose Z and it goes to the right. Okay, so whenever you put two arrays together that have a common endpoint, if you think about this, you have an array that goes that way and then an array that goes this way, that creates an angle. Now, angles are something, again, that we deal with all year long. So let's put some points on here. Here's A, and B, and C. So we need to know how to write the name of this. This is angle, and this is called your vertex. You've probably heard of that before. You can call this just angle A. Now, A is a point, so it's capital. If you just write A, that looks like a point, so you have to put the angle sign in front. And that works a lot of the time. But sometimes it's confusing when there's multiple rays coming out of one vertex. And I said, hey class, measure angle A. You really wouldn't know if I'm talking about this angle, or this entire big angle, because angle A is technically all three of those. So it's kind of like if you know three people named Michael. If only one of them's in the room, you can just say Michael, and not a problem. But if there are three in the room and you say Michael, they all kind of look at you like, are you talking to me? So what we're going to have to do is be more specific, like say Michael's last name, right? And then you know exactly who you're talking about. So if I name this ray or this angle, I would have to use some of these points on the ray. So the key is the middle, the vertex is always going to stay in the middle. So I could name this one angle BAC or CAB. Either way is perfectly fine. The middle letter has to be the vertex. So let's name this little angle. So remember, the vertex has to stay in the middle, so it could be CAD or DAC. Either one's perfectly fine. Now, if I want this big angle, again, your vertex is A, the angle's bigger, but that's okay. I could have BAD or DAB. So again, grading this stuff, I have to be really careful because there's many answers, and just go by the rules. Okay, vertex is in the middle. If it causes confusion, you have to use 3 letters. Okay, so if there's more than 2 rays coming together, just know you're gonna have to use all 3 letters or points to name it. Okay, so make sure both of these are on your definition part of your theorem sheet. Now, typically, if we were in class, I would give you a protractor and have you practice measuring, but this year's different. So we know protractors, they measure angles, and I assume that you used these before. Most people have at this point. Here's where people mess up. They're measuring, let's say, this green angle. And so they know to look right here. But there are 2 numbers. There's a 70 and there's a 110, and they just, grab the top number. So let's pretend you just always grab the top number. So that means that is 70 degrees. Now let's measure this angle. And so if you just grab this top number, it's 70 degrees. Does that make sense? Should an obtuse angle equal 70 degrees? And of course not. So you have to know which number to look at. And the way that you know is you start at 0 and you just work your way up. And you know that's acute, so that means it has to be 70. So 0 all the way up to 70. Now, if I go this other direction for this angle, I'll start at 0 and I keep going up, and there's 70, I keep going, and there's 110. Okay, so ask yourself, is this acute or obtuse? And that helps you decide which number to use, or just go from 0 and count up. A lot of people make silly mistakes here. Now, angles for this class are always measured in degrees. And if you don't know these, write these down in some notes somewhere. We need to know what acute angles are. Acute angles are less than 90 but greater than 0. Right angles are 90. Now, when you have a right angle, you can put the little box in the middle, and that means 90 degrees. Obtuse is more than 90, less than 180. If it's a straight, technically that's 180 degrees, so that's called a straight angle, and that's probably new. Now, a reflex angle, that's the dark shaded part. Notice it's more than 180, and we use these very, very rarely. So that's just a good word to know, but we really don't need it for now. And don't worry about full angle. We know a circle is 360. Okay, so we're going to practice measuring some of these. Now, the little m means measure, and then angle, K-A-E. So K-A-E. Now, this is actually pretty easy. You have a couple methods. You could count the little dashes, but to me, that's the more difficult way. Let's just take the top number, 130, and I'm going to subtract the top number over here, which is 70, and then get 60. Okay, so if you just subtract the 2 numbers, that's one way of getting the answer when you don't start at 0. Okay, and of course, this is acute. Let's just practice our vocabulary. D-A-N, D-A-N. So I don't start at 0, so I can take the top number, which is 160. And then I'm also going to subtract the 90. Remember, it can't be negative. So if you write 90 minus 160, just know it has to be the positive. You're not going to have a reflex angle on these. Okay, so when I subtract, I get 70 degrees, and these are acute. All right, next up, K-A-D, K-A-D. I don't start at 0, so 160 minus 70 is 90. This is a right angle. Okay, B-A-D. B-A-D. Okay, so I start at 0, so I don't have to, I can subtract if I want, but I can just go 0 up to 20. So this is 20 degrees, and this again is acute. Okay, so this is a you try. I want you to go ahead and pause the video and try to find these measures. When you come back, I'll go over them. Okay, so I'm going to go over these answers. LAD, 160 minus 70 is 90, and this is a right. So next one, KAC, 130 minus 30 is 100, and this is obtuse. Next one is KAC or DAC. So 160 minus 130 is 30, and this is acute. Let's do the last one. And CAB. Okay, so I'm starting at 0 and I'm going up to 50. So this one is 50 and acute. Okay, so again, if we were in class, I would have you measure these. If you have a protractor and you want to try to measure them, I have the answers on the next slide. So you can pause it if you like. All right, so here are the answers. And I mean, since your monitor might mess some of the stuff up, if your dimension on your monitor is different, maybe it's off. But the main thing is, are your numbers, at least if it's supposed to be acute, are they acute? And if it's supposed to be obtuse, is it obtuse? Now, one thing I want to mention is that when you are measuring, I think I forgot to tell you that these two numbers, like the 10, it always adds up to 180 with the number below it. So your answer could be off quite a bit. I just wanted to remind you that these two numbers always add up to give you 180. So that might help you when you're trying to find a number. Like if you can't read it, like if you can read that this is 20 and you can't read this top number because it's kind of messed up, just take 20 minus 180 to get 160. All right, sorry, got sidetracked. Just want to make sure I mentioned that. Again, here's the answers. And we are going to do a second lesson. And this is a middle school class and they meet technically every day. So we often have to do 2 lessons to try to keep pace since this class doesn't meet as much as an everyday class would. Okay, polygons and polyhedra. Okay, again, write down your definition. A polygon is a 2-dimensional figure and it's bounded by line segments. I believe that's a question later. And it lies in a plane. A polyhedron is 3-dimensional and it's bounded by polygons. Again, you're going to have to know that later. And it's in space. So you're going to have to know the names of your polygons up to 10. So a lot of these you already know. You know triangle. Now, 4-sided shape, a lot of people want to say rectangle or square, but we need the bigger classification of a quadrilateral. So make sure you say quadrilateral for 4 sides. Pentagon, hexagon, heptagon, octagon, and nonagon, that might be a new one, and 10 is decagon. Deca means 10. Now, technically, there are names for things, for polygons more than 10 sides, but for this class, we're just going to kind of do a cheater route. It's a mathematician way because, mathematicians are lazy. You're going to hear me say that a lot. But let's say you have a 12-sided. That's technically called a dodecagon, but what we're going to say is 12, put a dash, and gone. That easy. So what's a 100-sided figure called? Well, that's easy. 100 gone. Okay, so just know anything 10 or above 10, we get to do this little sheet for. Now these things, I know that you guys know, we're going to go over them just so it's official. Perimeter, that's the sum of the lengths around the side. So like here, there are 2 units, and here there's 4 units. So what is the perimeter? The perimeter is to add all of them together. So 4, 4, 2, 2, 8, 9, 10, 11, 12. Okay, let's say the unit is in feet. Is this feet squared or feet cubed? Whenever you're doing perimeter, it's just the unit, so it's feet. Now, let's do, that didn't work. Let's do the area. Okay, so again, 2 by 4. So you're going to add 1, 2, 3, 4, 5, 6, 7, 8, or multiply 2 times 4, which is 8. Now, is it feet squared, or feet cubed? Whenever you're doing area, it's always squared. Okay, so for your homework for this time, you're going to do lessons 12.1 and 12.2 online assignment. Again, you get unlimited attempts. You get to message me anytime for help, and know that you're going to need a compass for next class. We're going to try to figure out how to do constructions over a video. So I'll get to that soon. Please message me if you have questions. I can't help you if I don't know you're struggling. It's okay to struggle. I just have to know so I can help you. All right. Take care. See you guys later.